Hi there. Welcome to my demo of BDD and TDD techniques applied for the backend. I have here a sample CRUD REST server, create, retrieve, update, delete methods. It's a Spring Boot project using Maven, using an H2 database and Spring JPA entities. The coding is done in Java 11. On the testing side, I have Cucumber scenarios to describe the different business functions and unit tests using Mockito. Every test is run through JUnit with Surefire and Failsafe as Maven plugins. I've chosen a simple entity type, cities, for the main business model. Here's a look at the existing scenarios. As you can tell, the background is populating the database with some sample cities. We can then run the scenarios and see that the new city was added when testing the adding function, etc. For this demo, let's start with a brand new scenario representing the functionality we wish to implement. So let's go. So I've already prepared some scenarios. Here's a kata that I do to basically add a new entity and have a link between the two. Let's copy that over here. And I'll put a whip annotation here to indicate that all I want to do is to run this scenario. So let's just comment it out for now. Forgot to run the whole batch to make sure that we start off in the green. So let's do that. The way I run these tests, basically these are Cucumber tests. I run every scenario with a run configuration in IntelliJ, and this will run a unit test configuration before our Cucumber tests. To simulate basic Maven functionality, where you have phases. The test phase runs the unit tests before the verify phase, which runs the integration tests. And of course, the build will stop if any unit test fails to produce a green. And that's exactly what we want. So I've implemented the same thing here in my IDE with a run configuration that calls another run configuration. So service tests, Cucumber, starts unit tests first. Like this here. So before lunch, I do a build and run a unit test. Alright, so it has run all the unit tests, they were all green. Now it's running through the scenarios. Of course, to run through the scenarios, since I'm interacting with the REST server, I need to actually start the server, which is implemented as a Spring Boot application. And yeah, all my existing scenarios are green, so we can start. Let's uncomment that out and change the rank configuration. Of course, we're not gonna go very far because we have 3 steps that are not implemented for this scenario. We're going to start by implementing this first one. Now this looks very much like the one we saw in the background. We know about these people looks a lot like we know about these cities. So let's go into the implementation for that step. Bring it over to the right so we can see them side by side. Yeah, this will be our template for this step. We have a link here to another method. That's the one converting the data table to the list of cities. Let's do the same thing with people. People, since that's what we're actually going to get from the table here, which will come from this method here that we have yet to implement. What we need to do with those people is, let's say, people is like plural of person. So for each of these people, we'll add a person and convert the person to an entity. PersonDTO. Okay, there we go. So we have a lot of red. Let's start resolving these compile errors. Let's copy this method that reads the cities, people, people. Notice that I just straight out write the code that I want to see. I don't really care for now about the compile errors that I create as I go along. I'll resolve that. So we have a person that has a name and that is in a city. But of course, this is the DTO, the data transfer object, not the entity. So we need a PersonDTO. Let's make a copy of the existing CDDTO. It's always nice to have a template. It simplifies the creation process, let's say. Okay, so let's remove anything that we don't need for now. Let's make this as simple as possible. I think we'll need this code, but we can comment it out for now. Let's go back. All right, so this looks pretty good. Let's deal with this one first. So we do need it. To entity. PersonEntity. So let's do the same thing we did for the DTO. So let's just copy the city entity to the person entity. The table name is people. And let's make sure this imports from this class. Now, this was true for the DTO, but in this case, we already have a city entity. So let's change it to this. And of course, in a Spring JPA entity, we need to add the right annotation. So this is a many-to-one, since many people could live in the same city. Okay, so back to our PersonDTO. Now it complains about this. And of course, it's expecting a city entity, not a string. So we actually need to get this from a parameter of the method. It compiles. So it needs the parameter. Let's edit the lambda. Let's do this. And now get the city from the domain. The actual domain object, the Spring Bean, is auto-wired right into the steps implementation, which is handy so that it's the same code as used in production. More chances to find bugs out. So we need to get the city from the person. Yeah. Okay, so get city provides an optional, so we need to add code if it fails. This should never happen, but then again, it could happen. If it does happen, we need a way to throw an exception. Okay, so let's define this method. Person. This compiles. So good. Let's go ahead and execute the scenario for now, which will launch the unit test first. Basically, in BDD and TDD, which are very close disciplines, by the way, in TDD, you never write code except... okay. Let's move this there. We need to define the new method in the domain. And for now, I'm just going to leave a reminder of the fact that I have to implement this method. All this does is just a programming aid that throws an exception. And that's to help me work in TDD mode. Because basically before you can actually write code in TDD, you need to have a test that fails. Or, like in this case, a compile error. So I need to add a basic skeleton of the function with the proper signature for it to compile. That's like a failed test. And that means that at runtime, once I reach that point, I'll know that there's something I need to implement. Meaning there's a missing unit test. So first, in TDD, you write the test first, you write a unit test, and that drives the implementation of the code. So it ran all the unit tests, which is fine. And now it's running the actual scenario, trying to inject these people. Right, and already we're heading to the point where we're throwing our exception. So this was to illustrate the fact that we don't need to implement anything in a scenario. We can just go one step at a time. And coding in BDD and TDD, the only difference between the two is the kind of test to which we respond. In this case, I'm responding to a scenario. This error comes in response to this scenario. Basically, when a scenario fails, it means there's a missing unit test. I don't really believe in the principle that we should not duplicate the efforts and everything. To me, Cucumber scenarios as unit tests have a different focus. This is a business specification, whereas a unit test will be a technical specification. And basically, we should have unit tests that cover similar cases as the scenarios, so if a scenario fails, it means that there's a missing unit test. So we should write a unit test that mimics part of the functionality required by the scenario. A unit test should always fail first. So in this case, there was a missing unit test, of course. Let's go to the unit test. Here. Right now, there are two add functions for cities. We'll need to pass it a PersonEntity, so I'm coding this in an interface that I call test constants. Test constants is just a really handy place to define all my constants without extra keywords. Even though it's not semantically an actual interface, but I'm fine with that. And now for this person, we created the DTO, the entity, and now we need to create the repository. We should say mock person repository. So we need to define the mock. Of course, we haven't created the repository, but that's okay. One thing at a time. Make sure it points to the person entity. And for now, let's remove all this. And yeah, that works. Now I have an error because the duplicate version hasn't been renamed. I'm not going to patch up this test just yet. I'm going to focus on the first one. But I will throw an exception from it once I reach it, to have a reminder to fix it. Okay, let's go. By the way, every time that I launch the build, I have a hotkey that I've mapped to Control-Enter that runs the current run configuration. Every time I need to initiate the build to run the tests, I just do a Control-Enter. So a little bit of coding, Control-Enter to see the results. So BDD and TDD are kind of similar to coding with a compiler, right? When you code with a language that is compiled, like Java, what actually happens is that you get feedback. Now, we know this test was actually called. I like to see my tests, especially my new tests, fail the first time that I run them. It shows me that they are actually being run by the build, and it gives me a feeling of confidence for the rest of the steps. So now that we saw it fail, let's just implement this thing. Okay, so person repository, we need to save the person. I think that's because of my plugins. Anyway, it works. So good. Our new method is working, at least for the normal case. Now we have to implement the error case. This is handy. because I haven't modified the given section, so I still have quick access to this method, which I'll just copy. And in this case, we should get an exception. Let's just generalize it easily like this. This is instead of providing a different type of exception. In this case, I choose to do it this way. So, as I was saying, when you use a compiled language environment, you get feedback constantly. So that if your code doesn't compile into proper Java code, you'll get feedback which will show you which file you need to fix. Tests should be regarded as the same. It's a feedback mechanism for logic and business specification compliance. The code should fail a test, so we should verify the business functionality through the scenarios, and then at the unit test level, we should pretty much test the whole combination of factors. So here the duplicate failed to call find by name, which is not surprising since we just started writing it. Now we need the error processing that checks for the duplicate. A simple one-liner like this is like a guard clause. Person repository. This is a little bit weird, but it's still a useful inspection by IntelliJ. When you create a new class, if you do forget to use the component annotation, it saves you from a test execution, but repositories don't need that annotation, and we know the code works. So now the unit tests are passing. Ah, it's good. We are already reaching the SQL layer, since it's trying to find the people table, and it's not finding it. I'm using Flyway here, so all we need to do is edit the text file. We do have a link between the two tables, which will be the ID. Many to one yields a field like this. Of course, any changes at the database level will be detected by the Cucumber scenarios. Unit tests against the database are useless. Takes too long to start the DB. Integrated tests are made for that. Unit tests are really good with logic and making sure the right collaborators are used. Okay, it was able to create the people, it's just not finding the city of Longueuil. That's defined here. The principle here is that we're injecting in any order, which I need to do to make sure that the data is sorted. Here, if you notice, the information that is returned from this call should be sorted by the most people in the city to the least. Here we have 3 people in Saint-Armand, and we have 2 in Montreal and 2 in Toronto. When the number of people is equal, we sort by city name. So first, number of people, and then city name. I can tell you right now that the names of the people are sorted as well. There's actually 3 sort levels, and I've written the scenario in order to validate that the production code will sort properly. How will I be doing it? Not sure for now, but we'll do that one step at a time. So now it's trying to execute the next step, which is undefined. We have to define it. Let's find a template for the action method. This will be the new unit test for the method. This is our regular expression, right? So this is a minimum people. We need a new URL for it. URLs for the different REST server functions are defined very simply in a regular public interface, So that's the list of URLs along with the list of methods in the Spring controller that implements our REST server. Now, a city, if you remember correctly, is composed of a name and province. In this case, we want the actual names of the people. So this DTO is not okay. I'll create a new DTO just for output, which is going to be much simpler. The nice thing about copying a class like that, a similar class, it's already in the right package and everything, it's just a whole lot easier. Just have to make sure that the testing is done right to ensure consistency, etc. So here we have a composite DTO, not one tied to an entity. It contains calculated fields, let's say. Okay, so the name and the list of people living there. It's good, it's what the method from the server is going to return. So basically our contract is done. We could hand it off to whoever needs it. Maybe other people will produce documentation for the service. Since we're starting with the contract, that's possible. Of course, there's the question of validation, but we'll deal with that later. We're not quite done here with the scenario. As you can tell, we've implemented it. We defined the URL, which we are going to use right now, along with the parameter. And here we are referencing the unit test, which doesn't exist. It'll be a copy of this one. Let's comment out the given and verify for now. We need a constant for this. Let's create the expected object as a list of mocks. We're expecting cities, and we haven't done anything to return it. So let's run that. Remember, we're implementing the when. For the REST call, we're using the get method to issue our call. Right, and the REST server doesn't have the new method, which is defined in the contract, so let's define it here. And we already have a unit test for the get cities with people. Otherwise, I would have used implement to alert me to the missing test. But there is one. So let's return an empty list, which is the simplest code for now. Okay, as expected, my unit test is failing. So what should I do? The pattern is that normally the server interacts with the domain to get any data. We need to get something from the domain. What should we get? How should we implement that? Maybe I could write a complex SQL request which already provides me this information, but I'm going to say it's going to be a little bit hard. And in fact, it's going to make the SQL request a little hard to read. Instead, I'm going to be concentrating on sorting the people. I'm going to get a list of people. And I'm going to try to sort that by city so that each city gets grouped together. And I'm going to have another collaborator, a new class, that assembles these people into cities. I'm going to do a first query that returns me a list of people, and then I'm going to have a type of assembler that puts these back into a list of cities. And it also illustrates that we will be able to create an entirely new class with a specification that is more abstract, more utilitarian, built step by step. Using some pure TDD. Let's do it. The way we design all this is through the unit test. What I want here is a list of people with the parameters since it will be used by our SQL request. Yeah, let's just do that for now. So let's define the method in the domain. This is going to return a list of people. Let's put it in the right sorted place. And let's return these people. That will return a list of people. We could use our test constants, but this is just as good and we can see the data flow. Let's just run that. Now we're building our server logic step by step, not knowing the actual details, the low-level details of the logic yet. But we have a general idea of what we want to do, what should happen at the controller level. So here's a basic skeleton for this new method here in the domain. And here I'm sure I don't have a unit test and I don't want to forget. This is a message that was prompted to create code by the compiler. Next time it'll be because of the test. Let's call the domain to get the people. See, at the business level, it would be useless to specify that there are two technical steps. But at the unit test level, it's just the right place to specify that. We're not getting cities, of course. Now we need to call our new collaborator. Let's call it City Assembler. Calling it with the people, okay? Let's mock it to return the cities. Let's define the mock. Same thing as we did earlier for the repository, right? Let's create that. Now, this is a production class. Let's put it in the main directory structure. Let's go back to our test. Let's define this new method. This will return our list of cities with people. So basically our test is pretty much complete. We're going to go from a list of people and assemble them into cities. And that's what we should get as a response from the server. So remember, the unit tests drive our code writing from a technical standpoint. And Cucumber does the same thing, but from a business specification standpoint. So the two complement each other. Okay, so we're not calling the new method. Let's do that right now. Yeah, in this case, it is right. The main reason why we separate testing between service level and unit test level is that unit tests execute that much faster. If you're spending more than a few seconds in a unit test, well, they should be moved into the integration tests. Unit tests are there for almost instant feedback on whether everything is consistent. Good. So it seems like what we've been doing so far is working, or at least we're at the point where the next error is the missing step in the scenario. So let's do that. This is the same thing. We're actually getting an entire cucumber table as a parameter, as the expected value. What I'll do here is the same technique. And I want to compare my expected to a table that I'll build from the response payload. A table with two columns, city and people. Here what I'm doing is building a table from the actual values that I'm getting. What I want is my list of people, right? And I want them separated by comma. It wants a string, and the string is just a comma separated list. I already have a function that does this. So doing it this way is much simpler. You can tell what the code is doing just by looking at it. And the mechanism Cucumber uses to compare two different tables is really great to troubleshoot what you need to modify to make it work. It's a really nice feature of Cucumber. We're just about to call our scenario. Oh, instead of adding the step, I destroyed the old one. Let's fix that. Copy that. And let's just undo until the step is restored. And there we go. Yeah, okay, so what's happening now is we're getting a 404. So let's check our REST server method, which exists, but it's still missing the annotation. With the proper URL and annotate the parameter. These annotations also can only be detected by the execution of the integration tests. So from scenarios. but it's fine. What we want to do ideally is have as many unit tests as we can possibly have. I've said earlier that when a scenario fails, it's because there's a missing unit test. Let's just try to make that true as much as possible, but it'll never be 100% true. There are some things, interacting with the DB for instance, that we can only test from proper integration tests. Yeah, and we're hitting one of my implements. Good, so it's time to implement it. Let's write a test for it. Let's comment that out for now. Okay, let's run this. Oh, forgot about the implement. Let's replace it with an empty list. That will fail because nobody's returning the person entity, and that's what we expect here. We'll patch it up somehow here, but for now I just want to see my new test fail before I make it pass. Like in TDD, Red-Green-Refactor. That's exactly what we're doing. Good, failing like we expected. The domain interface to the DB through repositories, so since we're getting a list of people, we should use the person repository. No, it's a person repository, like city repository, singular. So it's fine. Okay, so yeah, we want to find the people in cities. This will return a list of people. Let's mock it. Again, you might ask why I didn't put the call to the repository already. Quick answer, I want to see my test fail first to validate the test, and I want to follow a basic principle of TDD. Do not modify production code unless it's in response to a failing test. So I want my failing test first. And of course, it's failing for the right reasons. At this point, I'm sort of expecting all of my unit tests to pass, and the scenario will tell me what I should be doing next. So some people have characterized BDD as being like a double loop, whereas TDD is a single loop. And it's true that you could view TDD as being the inside loop and the BDD the outside loop. But I just prefer to think about it as BDD, or business specifications, drive the technical specifications. So integration tests drive the writing of unit tests, which drive the writing of the code. There's your BDD right there. I'm always writing code in response to a failing test, be it an integration or unit test. I'm always just in a single loop, responding to a test. Okay, so I'm getting actually a Spring error. Find people in cities. It doesn't know what to do with that. This will be our SQL request. So let's start by writing this. So hopefully this should make it work. Now, since I'm not really operating at the unit test level anymore, I'll execute my scenario, but without the unit tests. We'll do it for the next iteration. That's okay. We should be nearly at the point of running our new query. My aim is to keep the query as readable as possible, even though we have to introduce some calculated fields. This will tell us if everything's right at the SQL level. Yeah. Here's another implement. It looks like the controller is actually going through the get people in cities to retrieve the list of people. It's in the assemble into cities that I left an implement. So it's actually hitting this point. It is getting the right list of people. So what we did in the repository, our query works fine for now. Of course, we'll need to evolve this query to give us the people in the right order for the assembler to work properly. But right now it's telling us that we should be working a little bit on defining the city assembler. So this is where it starts being a pure TDD exercise. I'll create a test for it. It's a unit test, so in this project, I've separated all the integration tests into a directory structure called IT, and all my unit tests are in the traditional test directory structure. I'll inject the mock using the Mockito annotation. And yeah, when I call it and I give it a list of people. I don't care about the ID. Linked with a city entity. If we had a single person in the database, what would be our result? I like to use a search A. Personal preference. It's really good and flexible. Is equal to a city and a list of persons. That's just going to be the first case for our test. If that passes, I want an exception to be thrown, indicating that I need to work on the next test. Since I have a unit test, I can do this for now. Let's verify that our new test is being called by the build. Oh, let's start again the unit test. So this is going to be our simplest case, a single person in a single city. In this case, we expect a single city having just a single person. And it's not doing that right now, of course. Let's make that happen. Let's make that pass. Let's just say we need a list of cities. And that's what we return. Let's loop through the people. I want to add to the city list city name from the person entity. And list of the person name. In TDD, one thing we're not doing anymore is design upfront. So we're not trying to figure out how the class or the method will work. We want the tests to be able to tell us that through feedback. As I'm building my tests, example by example, use case by use case, it lets me evolve the production code in a more natural way, with minimalistic results. Okay, so this example works. Next example, but before we do this, basically we need to call the class with different lists of people and cities. It's basically a truth table, right? There's various ways of doing that, especially with JUnit 5, which enables parameterized tests. But I find that just doing a simple private method of the test works very well. It's a simple implementation of the concept. Let's run that again to make sure it still works. Instead of using the next method, I could have just changed the run configuration. This will be a parameter. Let's see if that works. And good, it still works. Works fine, but it's not quite as readable as I would like. We'll define a private method in our test. This is just like a builder. And yeah, this is much more readable. And the way this works is that it will do an equals on each city. But as you'll see a little bit later, I'll introduce more test cases using the same pattern. Alternatively, we could declare this call in a separate test method, but we would just repeat this boilerplate code for nothing. I find this a little easier to manage, especially to implement a truth table with every possibility outlined. So yeah, here let's give it 2 people, and I want to make sure that the assembler doesn't do anything to the sort order that was returned by the SQL request. I'll put them unordered like this. The way they will be assembled is the same order in which they were received by the assembler. Let's run this. As you can see, it's a very handy way of describing the tests. At first, we only have a very simple scenario, and then we have 2 people in the same city. So we want to see that concatenation, that people are getting concatenated into cities. Okay, of course it doesn't. It gave me 2 cities, each with a person, which is consistent. We're going to need a bit more functionality here. Let's comment that out for now. What we need to do is something like this. If it's a new city for the person, then handle it as a new city. Otherwise, handle it as it's in the same city. Let's implement these methods. In this case, we sort of need a marker, a pointer. Which I'll call current city. And here, if it's a new city, well, let's just code for the simplest way for now. I want it to be a new city when the current city is still null. This is basically this one, yeah? Yeah. Cities is a local variable, but it needs to be a field. We need to make sure that current city at some point gets assigned a proper value, and new city is the place for it. And let's use the field. And in this case, when it's in the same city, it's much simpler. You can see also when it executes the tests, which subtest fails. IntelliJ highlights it by default with a rectangle so you can tell which case it was. Okay, so yeah, we are dealing with mutable and immutable lists. This is where we're adding a new person. The reason for this is because we constructed using an immutable version of the people list. Let's correct that right now. And add the first value to the list. So our production code has evolved a little bit. We now have an algorithm to assemble persons into cities, and we have two tests to validate two variations of the list. It's actually combining now, but it's working a little bit too well. It's combined all the persons we have named so far It's combined the two examples. We need to reinitialize for every call. We need to do clear. And we also need to reset our pointer. Good, that works. We're done for this example. Let's move on to the third case where it's not just the person that is changing, it's also the city. And this will pretty much conclude the testing of this assembler, since it covers all the cases that matter. We could of course do a null check, but unless it's prompted by a unit test, I won't do it. Okay, so it's combined everything into city2, so it's not detecting the change in city name. If it's the very first city, it should be true, or if the name is different, so not equals. Let's see if it works like this. One major advantage of TDD is you're writing code always in response to a test. So code coverage is really not an issue. You're only going to have the code that was called by a specific test for a specific use case. You should pretty much have 100% code coverage when doing this kind of logic. We can verify that by running the test with coverage in IntelliJ. You should see that every line of this code is covered. Yeah, and it is pretty much the case. Time to go back to our scenario. Let's run with unit tests for now, but it's time to work out the SQL query. and we won't need unit tests for that. It's going to speed up our development ever so slightly. You'll note that at the moment, we're not just focusing on production code. Rather than writing code towards expectations in our head, we're actually writing the tests as we go along. So our commit will contain all the changes required for the implementation of production code, and a complete series of unit tests and integration tests as well, in the same commit. Puts in perspective the waits that we have just waiting for the test execution for each iteration. An added benefit also is that the code is much simpler, as you can tell, when designed by TDD. Okay, so we're back at checking our results. So now let's make it so that the query sorts people in order of the number of people in the city. Let's disable the unit tests. Let's go back to our server side, the domain. Let's go to this method. In the repository here, here's our request. So we need to find a way to count the number of people also in the same city. We'll be doing it with an embedded request. So let's do it like this. What I'm doing now is that I'm getting all the results from a secondary request, and this request will contain calculated fields, allowing us to do an order by, a where, etc. Let's just make sure that these changes still work. So in this way, we can evolve our SQL request like we're evolving our code. If there's any error, without going too far, without writing the whole request at a time, and finding out that we have 5 or 10 problems to fix, this is a way to make it so that you only fix 1 or 2 problems at a time. Good. So our test is done. It's still producing results, so the request is fine. It's not producing the right results, but the request is valid. Okay, so let's start by introducing our first calculated field. So I'll sort by descending order of the number of people in the city. This is my first calculated value used for the first time for sorting. The nice thing at this point is that we've already written our city assembler, so we'll get, as a result, a nicely formatted table to compare, and that Cucumber can also compare. But basically, this makes it much nicer. Okay, we have a syntax error in the request. Ah, I put a comma here. See, that's one advantage of having SQL queries that are simple to make out, is they're also easier to troubleshoot. And yeah, the number of people per city seems to work. The table comparison, like expected.diff, this is what it gives you. It was expecting these rows, it's not finding them, so it flags them as missing with a minus sign. And the plus is what was extra that it found. As you can see, the entry for Toronto is correct. It's fine, we moved up a step, and it is sorting by the descending number of people in the city. Now we also need to sort by this person name. The name, because we're getting entries from the people table, so name will be the name of the person. So that first row here will be satisfied. That should bring us closer to the expected results. Okay, this works. Perfect. Why is Montreal out of place? Yes, it actually put Toronto, Montreal, and Longueuil. Montreal is not in the right place. We need to sort by city name before person name. We'll just introduce another lookup here. That should be pretty much what we expect as results. The only thing that is missing is that we're not taking into account the parameter. So we'll do that next, but I just want to see that the sort order is complete. All right, and it is. All that's missing is cutting off the cities which don't have at least two people, which is Longueuil. So we just basically want a green for that scenario. And yes, we have achieved it. Our code is functional. Very good. Now, we're not quite done yet. Let's go back to the template. So we have done the scenario. We've dealt with the background. We're missing a case for the validation. So now it's time to handle the validation. This is the new call that we have to check. We have to check that we have a bad request when we call the server with -1. This should be a minimum of 0, as outlined in our test. We have another test that ensures that every single request is fully secure. When calling it with a 0 parameter, it should work, and when calling it with a negative parameter, it should fail. This one's done. Let's re-enable unit test as well. You'll see the reason for that in a minute. So for this, we're basically using Spring validation. And the reason I'm enabling unit tests is that I have unit test code that can check Spring validation annotations to see if anything that's missing. So first, I was able to see that all unit tests are passing without issues. And now I'm expecting an error, at least at this method here, which I'll get because I haven't put in any validation for the parameter of that call. Good, so this test is failing. That's happening in the REST server. Our path variable does not have any validation specifications. The testing code at the unit level that I was referring to is here, using a method that I've implemented that is called validate. And it checks every method call that has parameters with the valid parameters that should be expected. Let's do it for the method which we just added. It's perfectly valid to call it with 0. If I call it with a -1, it should validate that it's lower than 0 and fail. And because it's a unit test, it'll be that much faster from now on to check. And as expected, our method call failed on the first invalid call. This is the same pattern as I was using in City Assembler. I find this a lot more readable, less verbose. This one is failing, so it's not validating the value. Let's go back to the server, and validation is actually done by the contract, which makes sense because that is the specification that we will give out to the consumers of our server. Here we need to make sure that the minimum value is 0. We have another validation error, but it's actually the next one, so we've progressed. So here we will also need a not null annotation. This time, hopefully, validation should be complete. You can see in the contract that receives a DTO, it will have a valid annotation to validate the DTO itself. And there's a similar unit test that validates that. And yeah, it's all working. So let's get back to our scenarios. So now this should produce a valid test. And it does. Good. Now let's run the whole thing to make sure that there's nothing else to fix. But now we're not running just the work in progress scenarios. We're running everything. Okay, so it's always a good thing to double check. Our changes have impacted some existing scenarios. Oh yeah, it's missing the Longueuil entry, which we added to the background. Right, so we've patched the scenarios that were impacted. Let's run again. This is just to make sure that we haven't made other mistakes. We pretty much know that everything else was working. So far, so good. Perfect. Everything runs fine. That concludes our demonstration. You can tell in the Git window that we actually changed 17 files. Including the SQL specification to add a new table, which is used by our tests. It's all fully validated. Oh, and earlier we renamed the city already exists to the entity already exists exception. It was a good thing that we renamed the exception instead of creating a new one, because it prevented us from uploading this reference here. Although this kind of error might have been detected by Cucumber as well. But this is a much simpler way. Let's take a look at what our business cases look like. We injected a new city, using it in a few existing scenarios. And we implemented a whole new functionality, which gives us the list of cities with people. So, thank you very much, and see you next time.